The second new rule we need to talk about is the quotient rule, because this is a little bit more necessary. So I'll show you where you do not need the quotient rule. You do not need the quotient rule if you have a single term on the bottom and it's just a polynomial, right? So here I'm dividing this polynomial by this polynomial. So I have a quotient. But the quotient rule, in fact, is kind of a pain in the neck. So I would always rewrite this, right? I'd kind of distribute this x squared under both of those. So this could be rewritten as x to the third plus 4 plus 6x to the negative 1 plus 2x to the negative 2. So this is just rewriting the function in a manner so that we can take the derivative easily. Right, 3x squared, 0, negative 6x to the negative 2, negative 4x to the negative 3. And that's easy. Here's where the quotient rule is needed. The quotient rule is needed when you can't do this. So I'm going to give an example that is a little bit easier. Let's use x to the third plus 3 over cosine x. So here's the quotient rule. And you want to kind of say this to yourself. And I know there's something that you learn in physics that I never got it straight. The derivative of the top times the bottom minus the derivative of the bottom times the whole top all over the bottom squared. Let's do another one. Let's take this example. Y is equal to, let's do 3x plus 1 over x minus 2. Let's make that 5x minus 2. For the quotient rule, the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Let's do another one. Suppose you have something like this. Y is equal to, let's say, sine of x over 3x to the fourth minus 2x. The derivative is going to be, we need the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So here's the quotient rule. You're taking the derivative of, let's call it f over g. We're going to take the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. And here's where the quotient rule becomes kind of useful, because now we can take the derivative of something like tangent of x, as long as we realize that tangent is sine of x over cosine of x. So this is going to be the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Well, let's take this a little bit further. What we end up with is cosine squared x plus sine squared x, which we have seen multiple times over the year. I'm going to write that as 1 over cosine squared x. So it turns out that the derivative of tangent of x is secant squared. The derivative of tangent is secant squared, and that's something else that you can memorize. Likewise, if we were going to look for something like the derivative of cotangent of x, well, now we can do this. This is just the derivative, in other words, of cosine over sine. So let's take the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared, which is going to give us negative sine squared of x minus cosine squared of x over sine squared of x. Let's factor out a negative 1 from the top, and that's just going to give us sine squared plus cosine squared. So the derivative of cotangent is, well, 1 over sine is cosecant, so this becomes negative cosecant squared. The derivative of cotangent is negative cosecant squared. And there's a little bit of a symmetry. The derivative of tangent is positive secant squared. The derivative of cotangent is negative cosecant squared.